Welcome to Board Prep Bites, where I post one board question, provide a rationale to make you more board ready. Here's this week's question. All of the following electrocardiogram changes are associated with hyperkalemia except. I'll pause here and let you select your answer. And the correct answer here is D, prolonged QT interval. So hyperkalemia slows cardiac conduction by depolarizing the resting membrane potential, which messes with sodium channel function. The resting membrane potential is primarily determined by potassium. There is normally much more potassium inside the cell than outside the cell. So potassium wants to leak out of the cell, and that outward flow keeps the inside of the cell negatively charged at that resting potential of about -90 in cardiac cells. So when extracellular potassium increases, the concentration gradient across the cell membrane shrinks. That less gradient means less potassium leaking out of the cell, thus the inside of the cell becoming less negative. So this causes depolarization of the resting membrane potential from -90 to about -80. Even though the cell is more depolarized, it's actually less excitable. And this persistent depolarization inactivates some of the fast sodium channels. And fewer available sodium channels means a slower phase 0 upstroke, resulting in that slowed conduction. So we would expect to see peak T waves, the classic early sign, a prolonged PR interval from slowed atrial conduction, and a widened QRS from a slowed ventricular conduction. This is why hyperkalemia causes dangerous conduction delays, not tachycardia. But here's the board pearl. A prolonged QT interval is not seen in hyperkalemia. In fact, the QT interval is often normal or even slowed because repolarization happens faster. A prolonged QT interval is more associated with hypokalemia or hypocalcemia. I hope this was helpful. See you all next week.